Okay, so as I was saying, today we will be doing some calculations, and I have already discussed most of the theory and also related concept to you, right? And I hope that today some of you will come on board and do those calculations. Again, it will be a sort of revision and also clarification for others as well. Sometimes we do have the habit of skipping some parts. Okay, so what are the calculations that need to be remembered or required, and what is our ultimate aim? Let me write it down. First is very important coefficient. Estimations for the half plus half spin systems. How do you calculate that? This is the first thing that we will do. Okay. Next, now this is, you see, this is again the spin system, right? Then from there, what will happen for three spin systems if we add three of them? So basically addition problem. Next is also addition. This is the second problem. And after that, we go to the flavor concept. And the next problem will be Meson wave function. So this is the next application. So number 1, number 2, number 3. And if time permits, then Subhadeep has done probably, right? The fourth one. And then the fourth part, which is the wave function of proton. Now, in this matter, before I invite you on the board, let me first say a little bit about this part, which is the wave function. So basically, what we intend to do is, we intend to write down the very basic ideas about wave function for proton, which is the lightest baryon, and also for mesons. Now, this concept of wave function is not new to you. From graduation, third year I think, you have been learning about quantum mechanics basic ideas. So, you have learned about the concept of wave function for a free particle. Right? Next term you applied those concepts to a hydrogen atom problem and all that stuff. Now remember, when we were applying these ideas to a free particle, so let me write on this part. So free particle. Now we are characterizing this free particle through a wave function, and then what was the argument of this? What was this wave function depending on? You remember, hydrogen atom problem, only the spatial component. That means we were considering a wave function, the spatial part only. Right? Now when we were solving the hydrogen atom problem, we were considering the entire hydrogen atom as a single system. Yes or no? Right? Single particle, free particle. Next application, hydrogen atom problem. In the case of hydrogen atom, we incorporated the Coulomb barrier. That was the potential. Okay, and there we use this spatial component. Now remember, this is a very basic idea when we are considering a very basic free particle. Okay, free particle in the case of, in the field of Coulomb barrier. Same, this thing we were estimating. Now we are going from graduation third year to your master degree last year, second year. Now what we are doing right now we are talking about composite systems. Free particle, next application was hydrogen atom problem, where the effect of Coulomb barrier was there, Coulomb potential. So now again, composite system, free particle. First is a free particle. Now this is a single system. A a single component, single unit. We didn't talk about what was inside, a very free particle. This is what we have done. Now, for the first time, we are talking about composite system. So, what's the most basic idea of a composite system? Reality. In reality, mesons, if you think about it, what is inside a meson? One quark and one antiquark, right? So this is a very basic example of a composite system. Now, to make matter, what should I say, interesting or complicated? You can think both ways, it's up to you. Now the thing is that this meson, this particular that I am showing you here, this is being characterized again by a wave function, the same concept. But this time, this wave function, there are several important parts of it and they are all independent of each other. What are the parts? The first is space component. Okay, since the meson is really there in the 3 dimensions, spatial component. Now spatial component of whom? This quark and antiquark. Okay, so this entire wave function will depend on the quark and antiquark spatial components. Now multiplied, why multiplied? Because the next part is entirely independent of the spatial component. And what is the next part? Spin, right. And why is this concept of spin coming? Because you see, these quarks, they are living in a 3-dimensional space or they are moving around. So we have to consider the spatial component of it. Otherwise, we will not be able to describe the motion of this composite system. Okay, the other features as well. The next part is you have to consider what other properties of quarks are there. The most basic property is this is a fermion, spin half. So where is the spin going? The spin will be coming over here. The spin information. Now you will say, okay, what's the problem? This is spin half, this is spin half. No. The thing is that if had it been a free particle, single unit, fermion, no problem. This you have done in statistical mechanics also. Now we are considering a 2-body composite system. So we have to add up the spins. Remember addition of angular momentum? Now we have to add up the 2 spins. And there the Slade-Gordon coefficient comes in. Okay? So this is where the Slade-Gordon coefficients will come. When we write down the composite spin part of this, taking into account the addition of the 2 spins. Right? What is the next component of the wave function? The next component is that you see these quarks, they can be of 6 types. U, D, S, C, B, T. Now which one is there? So flavor component. The flavor will identify either U is there or D is there or any one of those. So flavor. You can see, right? So space, spin, flavor. And this is again not the end of the story. There is another part also which is the color component, right? How many colors are there? 3 colors and 3 anti-colors. Remember, don't say that there are only just 3 colors. 3 colors and 3 anti-colors. So RGBs. Together we will have a colorless system. So 4th component is the color. Fine. So you see, from here to here, matter is becoming so much more complicated. And that's why we are now trying, and this is what we are doing. This is what we will do. We will estimate this wave function by calculating all the 4 components. Now here, I will be talking about the color part later on. Let me first write down the 3 parts here. Okay? Now in the 3 parts, you see, this part, spin, is more fundamental. This is very simple. Space. What will happen to space? Which polynomial will enter here? Spatial components, wave function. Check your copies. Check your copies. Okay, now you see what I am saying is that the spin component is very fundamental here, because this flavor, how we will be adding the flavor components again to write down the entire wave function over here. This will be very much identical to how we add the two spins. So if we do these calculations correctly, this will automatically follow. Now this is about meson, and here we have got a three system. Baryon, Q, Q, Q. So basically in this particle physics class we are going to calculate the wave function of a composite system. Two particle composite system, three particle composite system. So this is our aim. Okay. So who is the first? So let's first start with this part. Slave-Jordan coefficient. So who will show this now?
So the isospin
Isospin. Now where is the isospin coming into play over here? You say, why did we discuss about isospin in the first place? Probably you are not there in that class. You see, this is why you have to remain in all the classes. The concept of isospin was introduced to distinguish proton and neutron, right? There is hardly any difference between them if you switch off the Coulomb interaction. If we can switch off the charge, then they are identical, almost identical. Look at their masses. Now, yes, so the concept of isospin was introduced, but later on it was found that this very idea of isospin basically relies on the fact that the mass of u quark and d quark are almost identical. Why? Because for proton and neutron, this is proton, this is neutron, you have UUD and UDD, right? Now just one U and one D is different in the two cases. Okay, so the fact that there is isospin, that means almost near equal mass of proton and neutron, is because of the fact that because of flavor symmetry between U and D quark. So isospin is not fundamental. Fundamental is the flavor symmetry. SU2 flavor symmetry between U and D quark. Now if we incorporate the S quark, then we have UDS symmetry between the three, and that is SU3 symmetry that we have talked about. Okay, so this is the idea. So Wasim, now you start with the first calculation. Okay, sir? I am rubbing it down. You can do both of them. First, this one, right? And others do check your copy if there are any. Okay, good. So what is this 1, 1? The first thing. What is this?
One teacher component I said.
In English. So what is this one?
There are three components of I take three components, that is 1, 0, minus 1.
So this is basically I, and this is I3. Okay, this is I, this is I3. Right? Now I can have only three values.
One minus 1, and 0 have only one component, and that
okay. Do you understand this thing? So now he is decomposing, writing it down separately. plus half, এরকম করে লিখব, it can be forming 1, right? 1 and 0. Now this has got 3 components, minus 1, 0, plus 1, and this has got only plus 1, right? So this is what he is writing, 1 and then the component corresponding to this 3, and here it will be just 0, 0. This is what he is writing. বুঝতে পারছো? রিভিশন হচ্ছে, একবার সবাই চেক করবে। So now you are applying J minus operator. So Wasi, why are you applying J minus operator and not J plus?
So this is the highest state of this three states. This component is highest one, and above this it will become 0.
So J minus is what type of operator? Is this a spin operator or an isospin operator?
Spin operator.
Spin operator. Then I should write here. Okay, so this is a, since this is a spin, so it will be J and J3, not I and I3. The same thing can be done for isospin as well, where instead of J we use I and all that. So okay. তুমি যেরকম খাতায় করেছো একদম করে আমি দেখেছি, normalization and all that, do entirely like that. So this is basically a nomenclature, right? See? This one, up, down, the thing over here. Another last time, hey, question is no? Huh? He can rub the board, right? এখানে দেখো ভিডিও করছি এটা আপলোড করে দেবো। মেয়েরা এবার তোমাদের পালা। ছবি উনি বলেছে আমাকে দেখাচ্ছিল, ও আমি দেখেছি কিছুটা ও গন্ডগোল হচ্ছে কেন। You can drop this one. One is plus, other is the opposite of it. You should just write like this. Suppose this is plus, and the other one will be negative. Minus. Okay. So this is the half plus half. Okay, so this is the half plus half part. Okay, so now who will come forward to do the next problem? Half plus half plus half. কে আসবে? রোহান করেছে? সায়ন্তন হয়নি? ও তো আসেনি। এই শুভদীপ হয়েছে? হাফ প্লাস হাফ করেছো? করেছো? আসো। আমি এখন স্পিডেই আসছি। Let us stay with the speed for the time being. Later on we will move forward to isospin when we talk about flavor. So you see, when we will be talking about flavor symmetry, there I will be using the isospin algebra. So just instead of J, there will be I, but the entire formalism remains the same. আসো, পাতা নিয়ে আসো। সঞ্চিতা, তোমরা কোনটা করবে? মেশনটা। তোমরা দুজন ঠিক করো কে আসবে। এবার মেয়েদের মধ্যে ডাকবো। নেক্সট। ওকে, স্টার্ট। তুমি এটা নিয়ে এখানে করেছো না? এটাই নিয়ে এইবার তুমি ক্যালকুলেশন করবে। আর ঠিক আছে।
consider three spin-off system.
Write it down. So what you are going to achieve? Half plus half plus half. This is what you are going to do. Write it first.
Three spin-off system. When it's, the system is coupled, it will form a system like this. Sometimes it forms 3 by 2. First I consider system when the two spin-up system acts, and the momentum will be just like this. And after that I will add the next spin, and it looks like walking. And then consider the composite system.
Basically, half plus half, right? You should write like this. So first we are doing this half plus half. It can be either 0 or 1. Next I am going to couple this with 0 and 1 with half, and then the possibilities are half and 3 by. You write like this, then it is better to understand.
And when we consider the 3 by 2 spin system, that by 0. By 2 half minus 3 by 2, and then I set the composite system like this.
Explain why are you starting with 3 by 2, 3 by 2?
Because if I apply the operator j minus upon this, I will get the next 4 levels.
So the philosophy is like this. We have got 3 by 2 and half. Either we can start with half and then apply j plus each time and then get the other components, or we start with 3 by 2 and apply j minus and then get the other components. So Shubhadev is choosing this philosophy, right? You have to explain. Okay, proceed.
And I don't have to think much when I consider this like state. This only happens when the three spin-up states or systems just adding up. And easily I can write it. And if I like the system, the states which are coupled to form this state, it will look like this. And after that, I apply j minus operator on both sides of this system. J minus means j1 minus plus j2 minus plus j3 minus. And these three separated operators operating upon this side. This is j1, mj1, j2, mj2, j3, mj3. And these operators just lower the mj value there and lowering the system just by value 1. And probably this gives and remembering this, then I will apply this on these sides and I will get data addiction and just spin-up statement.
তুমি এখানে এটা যদি অ্যাপ্লাই করো, so you write it like this. So now he is applying j minus
On left hand side.
on LHS of both. So you write the result over here. right? The result of this. That's better. On this side, you write, so this will be the result over here. So write like this over here. Okay, this is better. Wasim also did like that, right? Yes. It's better to understand it. Those who have done the calculation, check if there is something missing. Aditya, you write a question. একবার চেক করবে খাতার সাথে।
Both sides h card will be cancelled out, and we can write the system. Down. Easy to understand that two spin-up states oriented in one direction and the other one in the just opposite side of the previous. So easily the spin is half because two spin-up states x and one is subtracted, so value will be half.
So this is the first step, right?
Yes, sir.
So basically, in the three spin system, you get 3/2 maximum. J3 component, right? So you apply J minus first, what do you get? Half. Next, again you apply. So this is the result. This is the result that you are showing over. He has done, right? Next, you again apply J minus, and then you will get minus half component, right? And then, so you have to apply 3 times, and then you will get minus 3 half component.
Yes.
Okay. So now, the other calculations can be done similar way. Write down the result. Okay. Result for this you have just, he has shown us right now. Now you write down the result for these two by rubbing this. ठीक है sir? করো তুমি যদি করতে পারো করো আস্তে আস্তে করে করো যাও তুমি একবার দিয়ে দাও না স্যার শুরু সিমেট্রিক আর অ্যান্টিসিমেট্রিক পার্টটা হাফ মাইনাস হাফ প্লাস হাফটা কর হাফ প্লাস হাফ বাকিরা হেল্প করবে ও যদি কোনো জায়গায় আটকে যায় হেল্প ইউ ইফ ইউ গেট স্টাক Next time,
consider the second subspace. Or that value will be half.
একজন একটা পার্ট একজন আরেকটা পার্ট
ও একাই করবে
এই পার্ট yes
So you get a half stage means total spin of the stage is half. So n the value will be plus half and minus half. Plus minus half. So when first write the stage, half and half. The same analogy here I apply J minus operator and lowering the state by one spin. Now I can write the system. The total spin is half, so I can write it. Can write like this. And this state will be simply I apply the orthogonal condition. This will be simply one, and this is my analogy. Looking this half, I have find a state that I have previously done. These state will be orthogonal to that state.
Okay, জিজ্ঞেস করো, ask him. He has a question. Ask him.
সাবস্ক্রিনটা প্রথমে একটা সিঙ্গেল স্টেট আছে না কি হয়?
Obviously this is come from singlet state.
সিঙ্গেল there is constant single state. Resultant speed will be of course 0.
J1 is 0 and half. I state is first 0.
Then it can only possible on the up spin and down spin and up spin.
দুজনে করো না, আমি তো বলছি যে এটা হচ্ছে ইন্টারঅ্যাক্টিভ ক্লাস। Yes,
It comes from the single state, that means it comes from either for the up spin and down spin and down spin and up spin. Initially, third spin is added to the third position, then in such a way that the resultant spin will be half. So that contribution from it plus up and it also plus up. So I think this will be the state if there is comes from the singlet state. Because the singlet state initially this is the 0. This two component gives 0 and third spin in such a way that gives half.
তোমরা দুজন মিলে করো। Are you convinced? Okay, you can also help him if you want. That way it will be faster to write down. Write it. We have other things to do. Okay.
It is also okay if the third spin is added in the first position. Or not in the second position, if third particle is added in the second position, it will be okay. But if we consider the convenience, the third particle added in the third position, then this will be, I think, this will be the better to use.
You can do. Any objection?
If there is we can add third particle in any position, then it will be okay. But if is the convenience that third particle will be added in third position, then
আমি যদি কনভেন্সটাকে উল্টো করি,
there is a written there asked by symmetry with respect to and with respect to first particle. So
বলো এবার ফাইনাল রেজাল্ট হবে, বুঝতে পারছো না অসুবিধা হচ্ছে?
আচ্ছা যদি স্পিনের কনভেন্সটাকে উল্টো করব, মানে দুটো আপ একটা ডাউন আছে, আমি এমন লিখলাম একটা আপ একটা ডাউন আবার একটা আপ,
একটা
একটা ডাউন আবার একটা আপ।
হ্যাঁ ওটা দেবে
ওটা
মানে আমি ওই উপরে যে এ সমান যেটা লেখা আছে সেটা ঠিক আছে, এর মতো কিছু লিখতে পারি তো। আমি কম্বিনেশন একটা আপ দুটো ডাউন বা দুটো আপ একটা ডাউন আমি রাখতে পারি। যেহেতু আমার সরি দুটো আপ একটা ডাউন আমি রাখবো, সেটা আমি বিভিন্ন কম্বিনেশনে করতে পারি।
এটা আমরা করতে পারি।
হ্যাঁ আমি বলতে ইউজ করি যে দুটো আপ একটা ডাউন যে কোনো কম্বিনেশনে আমি রাখতে পারি।
কিন্তু প্রথমে তো এখানে 1 হাফ থেকে তো এখান থেকে তো 1.0 আসছে।
হ্যাঁ
আমি তো সিঙ্গেল টেস্ট কনসিডার করছি, মানে ইনিশিয়ালি যেটা 0 দিচ্ছে, তাহলে ইনিশিয়াল যে 0 দিচ্ছে সেটা ফার্স্ট ওয়ান পার্টিকেল কনসিডার করছি।
আচ্ছা
Up down and down up in third particle at any such a way that resultant spin and spin and component spin both being half and half.
আচ্ছা ঠিক আছে ক্লিয়ার বুঝলো এখানে বুঝলো
কমপ্লিট ইট। শুভদীপ তুমিও কমপ্লিট করো, দুজন মিলে করো তাড়াতাড়ি।
ওটা ঠিক আছে, ওটা শুধু এখানে চেঞ্জ করলে চেঞ্জ হবে, তাহলে
আমি চেঞ্জিংটা বুঝতে পারছিলাম, মানে একটা হাফ আর একটা হাফ দুটো হাফ মানে আমি 1 হচ্ছে একটা 0 হচ্ছে। আমাকে যেহেতু আমি সিঙ্গেল স্টেটটাকে নিয়ে কাজ করছি তাহলে আমাকে রেজাল্টেন্টে একটা ডাউন সবসময় রাখতে হবে, ওটাকে সামনের দিকে বসানো যাবে না, সেটা করতে চাইছিস
এন্ড থার্ড পার্টিকেলটা লাস্টে ঢোকাই
লাস্ট রাখতে চাইছিস। ঠিক আছে এটা অসুবিধা নেই স্যার, বুঝতে পেরেছি।
ঠিক আছে? Okay, now these calculations can be done similarly and then we will do the orthonormalization, right? Now write down the final result. लिखे दो। Any objections, anyone? Everything is fine?
As a considering this, there is slightly difference in the coefficient, CD coefficient or coupling coefficient. Please check.
This we have done at home.
According to my comments. If we first consider the single state, there will be slightly difference in this probably in this type. And this wave function will be antisymmetric under 1,3 exchange of the 1,3 spin particles. And another thing that will come from the triplet state.
So these are the 4 components.
And there are some will be symmetric and some will be antisymmetric under the exchange of the particle 1 and 2.
J is equal to 3/2 component. Now this is half component. Okay. Fine. So, ठीक है. Who will come?